Hi guys, this is the third video for the laser cutter build. What I'm going to be doing today is a bit of the electronics. The control board for the mill and the control board for the laser are very similar. And what I want to do is convert both of them to use Arduino Megas running effectively pretending to be ramps boards. So I'm going to take the same pin allocations for the ramps boards and I'm going to then ribbon cable them to the Arduino Mega. Ribbon cable the pins for a ramps board and ribbon cable it over to the driver boards. So we're going to have a quick look at the driver boards now. I've recorded some footage earlier of me removing it, so we're going to take a look at that. I've got a bit of footage of me talking about the way the pin allocation works. I'm then going to right now work out what the pin allocation is on the header that's available on the mill controller board, because I need the mill working before I can cut the bits to make the laser cutter. I've got a document which I'll link in the description. It was a very useful document by a guy called White Quark, who has a lab book explaining the inner workings of the mill controller board. And this is a CNC 3020 T, I think. Yeah, it's a 3020 T, which is basically a cheap desktop mill from China. In fact, actually, there it is. I got that out of the shed the other day, cleared it off a little bit. It's covered in dust. There's a few little problems with it. There's no limit switches. This is quite limited. I need to put some limit switches on it, which I will probably do. The functionality on the board is great. There's tons of functionality for like pulse width modulated, like speed control of the spindle. Actually, on the thing as it comes stock, it's really like most of it's not plugged in. It's very odd. I mean, the White Quark was saying in his document that PWM spindle control with the speed feedback is a jumper. You put a jumper in and you do two wires between the control board and the spindle controller, and it's done. It's ridiculous, isn't it? It's very strange. Maybe they sell that as an add-on and you get those two wires for like, $800 or something. What we're going to do, jump in, get the mill electronics working. So this is a little bit of a side, we're going like to the laser cutter via the mill, but actually the electronics for both are very, very similar and the control is almost identical. So let's get on with it. Okay, so this is the controller board for the mill, and pretty much exactly the same as the one for the laser cutter. It has a parallel port input and stepper driver for each axis. I've marked these as 1, 2 and 3 and taken a photo so I know where they go. All the other connectors are like kind of mutually exclusive. And what I'm going to do is there is a row of headers here, and I'm going to solder a ribbon cable into those. So the ribbon cable is going to come out of here and it's going to go up in, and then I'm going to have the Arduino Mega. Eventually I'm going to put in a milled plate, probably 3mm MDF or something, just to hold all of the extra stuff. But for the time being, it's just going to wrap it in bubble wrap and some ESD bags or something. Okay, so here's the driver board. It's out of the enclosure. I've taken the heatsink off the bottom. That was just mounted on with 3 screws and the plate and the transfer stuff here. Put my phone somewhere. So this header is connected to this. It's not in pin order, so pin 1 of this isn't pin 1 of that. However, it does seem that all of the pins that are actually relevant on here are connected to that. And actually most of this side of it is connected to a ground strip. Okay, so what I'm going to do is I'm going to get the multimeter out and I'm going to buzz between pins here that I need, because I know the pin numberings, and pads on here. And I'm going to write that down and make up a table to say what goes to what. And then I've got ribbon cable, which is what I generally use for all my Arduino projects and stuff. You can see from this end of it, I've gradually been chewing bits off as I need them. And we're going to take out the ribbon cable for that. Now, what I have is someone's already done an analysis of this board, like a kind of a reverse engineering of it. This is whitequark.org, and this is White Quark's lab notebook. And he's basically taken this apart and and done all the electronics for it and all the pin outs for all of the things, except for that one. But I'm trying to scroll here while doing it. What we do have is the parallel port pins. Pin 1, I've basically got the pin allocations for that, and I'll put that up on the screen now. So what I need to do is go from here to here, and then get a ribbon cable out, and then I'll have the colour of the ribbon cable also in the table to say what needs to go into what pin of the Arduino Mega. And then I haven't got the Arduino Mega up here. For the time being, what we're going to do is just tin the end of the wires and poke them into the Arduino Mega. Eventually I'm actually going to get, I've got some prototype board, I can't find it right now, and I'm going to do that. So yeah, I mean the other thing that I've got going here is I've finally got my office. This is the Lars chair view. So finally I've got my power supply and my soldering station wired up. I had this is the first time I used it today to do some stuff for the polytunnel with the temperature probes. I'm going to write up a blog article about that, and that's really nice. I've got a load of crap on here. This is where I was working with the Raspberry Pi. Yeah, so I've got all of my bit boxes. Well, not all of them, to be fair. I've got a ton more of these all sitting in the house that I need to start bringing down here and stacking up. But yeah, it's a start. So the computer doesn't work. The computer's taken up half the desk and it doesn't actually work, which is a bit dumb. Okay, so I've printed out White Quark's document. Here's the table showing the parallel ports, which direction they are, what they actually do. I've added in header column for the little header here, the ribbon colour, and the Arduino Mega pin. The Arduino Mega pins have come from a forum post discussing the pin out for the ramps boards. I'm going to need to double check these, and I'll double check these in the firmware setup in the pins.h in the firmware. But as far as I know, it's these. I've added in, as you can see, the drive only has X, Z, Y, and X limits. I've added these in because there's a minimum and a maximum. But right now I don't have a plan as to whether to do minimum limits or maximum limits. It would make sense to do minimum, but like something like the Z axis would probably have to be a maximum. So I'm going to do that, and I need to think about that. So what I'm going to do now is I'm going to go through and buzz between these and the header, and then once I've worked out which header pins they are, I'll then assign ribbon cable colours. So I've got quite a range to work on, and I only need 6, 7, 8, 9. I only need 9 things. There is a spindle direction, coolant pump, all that sort of stuff. There's an e-stop as well, and a spindle pulse width. I don't have any of these currently installed. I might do in future, but right now I'm not going to bother. I just want to be able to control it from the laptop and get it done. Just basically cut basic shapes. So I'm just going to be using it as a router to start with. Alright, so what I've done is I've gone through, I've got all of the pins, and they seem to follow a fairly logical pattern on there. It probably would have really helped me figure this out if I had actually already known. Silence! If I'd already known that pins 17 to 25 were always ground on a parallel port. I didn't know that. I have learnt that now, and so yeah, I had to go and look that up on Google. So that would have explained why most of these are tied together down one side, and from that I could have worked out like the pattern as to how they were doing pins on this. Anyway, so basically all the pins numerically down here were all the ones on this side, the the probe is the only one that doesn't follow that pattern really, and is on that side, and the rest of them all ground. So what I'm going to do is I'm going to draw this up in Excel, and you'll see a pretty version of it on the screen now. Thanks, probe. And through the magic of editing, there we go. So as you can see, I now know what I need to wire up to what. I've got my ribbon cable colours, I've got my ribbon cable. I did make a slight mistake with the mega pins for the input and the output. I'd listed those when I wrote them out on the paper as X, Y and Z, whereas on the pin out on the parallel port it's actually Z, Y and X. So I've got that. I've put those the right way around, hopefully. And right, so I'm going to take the ribbon cable, I'm going to clear off the end, and I'm going to start, I'm going to tin all the ends first, and then I'm going to get those soldered in. So I got all that soldered, and what I'm doing now is I'm just going to temporarily put it on here just to run it on the machine and make sure it works. The only ones I'm going to connect at the moment are ground, the axis step and direction, y-axis step and direction, and x-axis step and direction. I've got these here, which are hang on, let me just write this down. The actual Arduino Mega output pins. This is the x-axis, this is the y-axis, and that is the z-axis. And what I'd actually got up here, this is the actual Mega pin, which you know, is a bit useless to me. So what I've done is I've actually confirmed those against the where is it? The ramp schematic. I don't know if you're going to be able to see that. There we go. So I've pulled up the ramp schematic off of the wiki. Where are we? Here? No. Yes, that's the wiki. So I pulled up the schematic and I've just gone through and grabbed the pin allocations to the Arduino footprint. So these wires are too thin. They don't. I was hoping I could just push them in and they'd latch in. Just use that temporarily to test it. What I'm actually going to do is I've got a bit of prototyping board here. I've got some pins somewhere. I'm going to go and put some pins in this so that it sits down on top of the thing like a temporary shield. Basically, I'll probably do it that way up, and then I'm just going to solder the wires on. So it's going to be a bit messy, but it will be good enough just to drive it around and test it, and we'll go from there. Right, so all I had was double wide terminal strip. Be quiet, Daft Punk. So all I had was double wide header strip. So what I'm going to do is I've cut out two each, and all of these pins are next to each other. So what I'm going to do is I'm going to stick these in where they need to go, and then I'm going to drop that on top and then solder them in. And hopefully even I can't cock that up. Okay, so I've come through to the main room, and I've just grabbed the mill, the control box. I've just screwed the heatsink back onto the bottom of this. This is all sitting together now. what I'm going to do is I'm going to screw it into here. I'm going to plug everything in. I'm going to put that in a plastic bag, or wrap it in a plastic bag just to keep it from ground shorting out on anything. And then I'm going to turn it all on, and hopefully that doesn't explode. Yeah. So then what I've got right now on my laptop, I'm downloading the Repetier firmware. I have set that up as best I can with all of the right stepping directions from memory and from the web. I've disabled all of the extrusion and all that sort of stuff, and what I'm really hoping is we'll be able to get into Pronterface and drive this backwards and forwards and side to side, or Repetier host, or whichever. I can't remember what I've got installed on my laptop right now. Okay, so I powered it on. Didn't explode straight away. Didn't explode at all even. One thing that happens is the one of the status LEDs on the Arduino lights up, and that was with it out being powered. I've taken the multimeter, I've checked all of these pins against ground. They are all floating at 5 volts. I think it's very negligible power because the LED was barely lit, it was just like very slightly on. And then when I've plugged it into my laptop to burn the firmware, which is what's going on at the moment, that's on full. The LEDs are like really bright, so I think there is a small amount. This is floating at 5 volts when it's not being told otherwise. That's interesting. I don't think it's a problem, and if it is a problem, we're probably going to find out when we try driving this. Okay, so I'm going to go and finish getting the firmware on there, come back with it written. Okay, so that's up. It's got the firmware on it. I've got Repetier host open here. It's connected. So one interesting thing I just wanted to show you was, let me see if I can drive my computer through the camera. The driver wasn't recognised. So the driver wasn't recognised, and what I had to do was go to update driver software, browse my computer, let me pick from a list of drivers, and then I picked Arduino LLC, and then in this list here I picked Arduino Mega 2560. I just had to manually tell it that that's the driver it had to use for an Arduino Mega. All the Arduino Unos and the Sanguinalolu type stuff I've got for the printer seems to work fine, but I had to go and tell this that it needed to get the right driver. Okay, so I'm now connected. I have no idea what that was all about. Got my manual controls. I'll set the feed rate low. So what I've done is I've plugged in just the X and the Y axis, as you can see, like that, and not the spindle and not the Z axis, because while I've probably got enough time to stop it, hit the E-stop if it goes that way or that way, if it jams the bit right into the bed. It's only going to put it into wood, but you know, the less I stress out about it. I've also just been looking at this thinking I should really clean it. I kind of, as the proverb goes, or as the saying goes, rode it hard and put it away wet. So I'm going to put the power. Yep. Do I still have communication? So I'm going to step it 1mm and we're going to see what happens. This is 1mm on the, I'm not sure what axis. Presumably the X axis, but we'll find out in a second. Okay, so two things went really wrong there. One, that happened, and two, my E-stop is broken. Yeah. So I was mashing random buttons there trying to stop that. Okay. So that was 1mm of movement. And I can hear you all you all at home saying, no it wasn't. So, stuff moves. Why did it not stop? Okay, right. So let's turn it back on. Oop, no, let's not turn it back on. Let's e-stop. I've just hit the software e-stop on there. So that was still trying to drive back into the end stops. Okay. That's still trying to do that. So I've just disconnected the Arduino from the computer. So that's really weird, and the other thing that's really weird is that that's happening. So there's something here is generating a very small signal there. So I think what I'm going to do is try to figure out why that is. If anyone has any ideas, I'd love to hear them. Yeah. Okay guys, so I've been working on this on and off for a couple of days now, over the weekends. I think it was probably 3 or 4 days since I recorded the last bit of video you just saw. The shield, or the little carrier board, or interface board between the step motor driver and the Arduino has gone through about 3 or 4 iterations. What I'll do is I'll go through with photos of that and of each one and just narrate what I was doing. I ended up doing taking a couple of different approaches to that. I kept getting a recurring problem where I had pins that were floating at slightly odd values. Or I thought were floating. What they were actually doing is they were being pulled low by an intermittent contact between one of the little in the kind of the multi-strand cable. One of the little bits had flicked out the side of the of this. I don't know how well it will focus on it from this angle. There we go. So it flicked out the side of this header where it's soldered on, and it was bridging across to a ground pin. So I was chasing ghosts basically. I thought it was a problem with or I'd possibly broken the Arduino by powering it backwards through the input pins. It's not the case, I hope. I think I fixed it now. I'm going to plug it all in and we're going to go see if it works. Okay, x-axis plus, x-axis minus, y-axis plus, y-axis minus, z-axis plus. I got the feed set much slower on this one. And we'll just do a z-axis negative. So I could potentially change the z-axis max speeds and invert it. I noticed plus is into the table. On the previous setup in EMC2, it was positive was up and negative was down into the table. But other than that, good run so far. What I'm going to do is I'm going to stick some G-code into it and see what happens. This is running a Prontoface as a simple G-code file. Should just draw a little shape, and I'm going to have my hand on the stop switch just in case. Alright, I was going to hit the E-stop there because that was going much further back than I expected. But, good run. Can't say it works. Z-index needs to be inverted. That actually did cut up into the material rather than down. But yeah, brilliant.
So there we go. It's quite a nice clean cut. If it was a down cutter it would have been an even better cut, but it's unfortunately an up cutter, so it's pulled splinters up off the top there. But you know, a bit of sanding would obviously fix that. The actual bottom of the cut is nice and smooth. The cutting speed was good, I was quite happy with that. Obviously the x-axis is inverted, so it's gone down, sped across there, which was a bit scary, and then it went back up into the cutting piece, so obviously that needs to be reversed. That's just a firmware setting, but yeah, that's come out really nicely. Awesome, okay.
Okay guys, thanks for watching. This is the third video in the laser cutter build. So, we've now got a basic control system that can then be applied to the laser cutter. They're both very similar stepper motor driver boards. There were a few changes. I've made text notes throughout the video, just explaining some little pieces, and on GitHub I'll have the code itself that I've changed. I'm not really sure what happened there. I was like very tired while I was doing the pin allocations and got myself completely confused, which was a bit ridiculous really. Anyway, alright, so the next video is going to be the laser unboxing, and if you look over my shoulder, there it is. So yeah, that arrived yesterday afternoon. I've been basically putting off unboxing it and doing an unboxing video until I've actually caught up on all my editing work, because I've got loads of daily vlog videos which I've left piled up and not edited. I've got those done now, they're uploading. And I've had this video which has just taken, what, like 4 hours to edit. Yeah, okay. Right, brilliant guys, thanks for watching, and I'll see you in the next part, which will be the unboxing. So I'm going to go and film that now. Yeah, awesome. Alright, rock on guys, bye.